Hi, good morning guys. It's Miss Scott coming to you from Miss Scott's room here to talk today about horizontally launched projectiles. So, you have projectile launched horizontally. How do you find your other variables? That includes horizontal range, final vertical velocity, and time. So, let's start by identifying how we know if something is launched horizontally. If something is launched horizontally, what that basically means is that it's launched 0 degrees above the horizon. So when I say 0 degrees above the horizon, that's all that means. So here's the ground. I have some elevated platform, and I'll launch it straight out like that. In theory, if I turned off gravity, we know projectiles have no horizontal acceleration. Their velocity stays the same. If I launch it horizontally, whatever velocity I launched at, it would travel horizontally at that velocity forever and ever and ever. But we know that's not true here on Earth because we can't turn off gravity. It changes velocity vertically. So we're going to see how we find that. Let's say I'm here at school and I'm standing on top of, let's say I'm standing on top of J building. And I'm going to say J building is 10 meters high. I don't know. The J building is 10 meters high. And I look, I'm standing on the edge of this building, and I see my friend standing over right about here. Let's say he is 17 meters away. So I see him, he doesn't see me. I am going to play a little prank on him. I'm going to throw a water balloon at him. So here I am. There's my water balloon. I want to know, A, how long is it going to take for the balloon to go from here to here? And what velocity do I need to throw it at? Again, I'm launching this horizontally. I'm only giving it initial horizontal velocity, so I'm going to specify that it's horizontal. So let's focus on time first for just now. So I want to know how long is it going to take for how long is it going to take if I throw it, how long is it going to take to get to here? And you might be saying, well, you don't have your horizontal velocity yet, so you don't know time. You can't use time using horizontal variables, but we know that if you launch a projectile, all projectiles are under the influence of gravity and gravity alone. If I throw this and I dropped a balloon from the exact same height at the exact same time, they would both hit the ground at the same time, in theory. In practice, not quite so much, but again, we're just talking theoretical physics here. So, I'm going to find how much time it takes for it to get from here to here using the formula time equals the square root of 2d over g. D is your vertical displacement, and g is your acceleration due to gravity. That's why it's a g. This, if you want to know where I got this formula from, this is just a rearrangement of the formula y, that's vertical displacement, equals VIY, initial vertical velocity, times time, plus 1/2 vertical acceleration, times time squared. Now, again, like I said earlier, like I said a few minutes ago, when I launch something horizontally, I give it no initial vertical velocity. Its initial vertical velocity is always 0 meters per second. So I can go ahead and sub that in. 0 meters per second. If that's 0, I can go ahead and get rid of this whole term, because anything times 0 is 0, right? So 1/2 AY times time squared. AY is acceleration vertical, that's always due to gravity. That's that. Y, same as vertical displacement. If I rearrange this to get y all by itself, first I divide by 2, That's the same as multiplying by y, or, excuse me, dividing by 1/2 is the same as multiplying by 2. Dividing by 1/2 is the same as multiplying by 2, Divide by ay, which is the same as gravity. And then to get rid of the square, I just take the square root. So it's really the same equation, it's just rearranged for us already. So it makes our lives easier. Alright, so T equals 2d times g. I know g here on Earth is always negative 9.8 meters per second squared. Negative, that just means it is being pulled down. It's going in the downward direction. Remember, acceleration is a change in velocity, and velocity has a direction because it's a vector. D, displacement, again, that has a direction as well because it's a vector. My magnitude is going to be 10 meters. That's how tall the building is. But it's falling down, so I'm going to go ahead and label that negative 10 meters. From here you just saw. So that would be, and I'm going to go ahead and simplify that. Negative 20 meters divided by negative 9.8. I get 2.04. 2.04. What I would ultimately be left with is seconds squared. Once you take the square root of that, not that button, 2.04. Excuse me, 2.04. Square root 2.04, and the time I get is simply 1, and I'm going to do this 3 sig figs, 1.43 seconds. So, regardless of how fast I throw it this way, it's gonna take it 1.43 seconds to reach the ground. If I drop it straight down, it's going to take 1.43 seconds. So, using that, so I got my time. I can now find what horizontal velocity I need to throw it at in order to get 17 meters in 1.43 seconds. All that is, now I'm using horizontal variables, so I'm going to label them x, as in the x-axis. X, which is 17 meters, equals VIX times time. I don't have to do anything with acceleration because there is no such thing as horizontal acceleration with these projectiles, only vertical. So, sub 1.43 seconds. From here, it's just simple algebra stuff, super easy review. That's seconds, not a 5. So 17 divided by 1.43. And again, the answer I get, I'm going to round to 3 sig figs. VIX, horizontal velocity, or VIX, if I want to hit my friend on target on time, it's going to be 11.9 meters per second. 11.9 meters per second. So that's how I did that. You may come across problems where it asks you at what velocity does the object strike the ground at? What vertical velocity does the object strike the ground at? So we're going to do that. Vertical velocity. So I know vertical, I have vertical acceleration because gravity is influencing it. When I first started this thing, like I said, it had no initial vertical velocity. I was just launching it horizontally. So it had no vertical velocity, but as it travels, as time increases and it's accelerating, its velocity is going to get larger and larger and larger. And so I'm making these arrows larger and larger. That magnitude is going to increase. So, how do I do that? How do I find my final vertical velocity? So all I would have to do is use the formula VFY, velocity final in the vertical direction, equals VIY plus AY times time. So I'll substitute my variables. VIY is 0 meters per second. AY is negative 9.8 meters per second squared. Time is 1.43 seconds. Obviously, anything, when I multiply these terms together, negative 9.8 meters over seconds squared times 1.43 seconds. I just put that over 1 so I can see how my units cancel. I'm going to get rid of one of these seconds, get rid of those seconds. Negative 9.8 times 1.43, and the answer I get ends up being negative 14.0. That 0 is still significant because I included a decimal, so I measured precisely up until this point. Meters per second. So when this balloon hits my friend, when this water balloon hits my friend, it's going to be going that fast, vertically. So we have found final vertical velocity, final initial horizontal velocity, and time. If you have any questions about how I did any of this, please comment, and I will get back to you ASAP. Till then, have a great day.